All right, my friends, let's take a look at problem 3. I know a lot of folks probably only want to see maybe part D or something. You're, of course, I'm sure you figured this out, but you're, of course, welcome to, jump to that part of the video or, watch me on 1.5 or double speed, of course, whatever works for you. For this problem, they give you the graph of G, and then they tell you that the graph of this continuous function G, and they're telling you here the most important piece of information, that the graph they've given you, G, is the derivative of f. So that's really important there. And the function G is piecewise linear from -5 to 3, and the definition of G is given as, for the parabola part, from 3 to 6, it's given as 2 times the quantity x minus 4 squared. Okay? So now for part A, it says if f of 1 is 3, what's the value of f of -5? So for this part, let's just think about the fundamental theorem of calculus. So we have information here on the picture about f prime. So if you use 1 and -5 as your bounds, then, oops, oh dear, and you put f prime in there, then you would end up with you'd end up with f of 1 minus f of -5, like so. Okay, so then from here, since f prime is G, this integral would be the same as the integral from -5 to 1 of G of x dx. And then f of 1 is 3. So just to be clear, I'm just doing these two substitutions. There we go. And f of -5 is what we're trying to find. Okay, now for the integral from -5 to 1. So that would be, adding up y coordinates starting at -5 and then stopping at 1 here. So let's do that. I'm going to break it into a couple pieces. So we've got this little square here, which looks like a 3 by 3. So it looks like that would have an area of 9, which means but it's underneath the x-axis, so you'd have an integral value of -9 for that part. And then this little triangle, what is that? A 3 by 1. So 3 times 1 divided by 2, so you've got a -1.5 there. And then this triangle right here is a 1 by 2, and so you'd get an area of 1 there, and your integral value would be +1 because you're above the x-axis. So for the integral value, you'd have whatever -9 minus 1.5 plus 1 is. There we go. Okay, so we've got negative, what is that, -10.5 plus 1, so -9.5. Like so. And then just a little algebra, maybe you could add the f of -5 over and then add the 9.5 over, and you'd end up with f of -5 is equal to 12.5, which, yay, matches what they had on the scoring guidelines. Okay. Okay, now for part B. Part B says evaluate the integral from 1 to 6 of g of x dx. Okay, so for this, so we're going from 1 to 6. I would break that up into this square here, so this piece right here, and then we could use an integral to get the rest from 1 to 6. Okay, so we would end up with, so for the square, it looks like a 2 by 2, so now that 1 looks like it's in a bad place. So anyway, the area and the integral value there would be 4. And then we would need to figure out what the integral from 3 to 6 of g of x dx is, like so. And so that would be 4 plus the integral from 3 to 6. G of x from 3 to 6 is defined as 2 times x minus 4 squared dx. Okay, and then for the sake of the video, I'm going to be showing a lot of steps, and I hope everybody knows that you could have your own style and show what steps work for you, as long as you have something that makes sense and leads to an answer here. So for the integral here, I'm going to let u equal x minus 4. Notice that with that, my du is just dx. And then I'm also going to change my bounds. So if u is equal to x minus 4, that lower bound of x equaling 3 would mean my new bound would be 3 minus 4, or -1. And then the old bound of x equaling 6 would turn into a new bound of 6 minus 4, which is 2. Okay, so now we've got 4 plus 2 times the integral from, let's see, -1 to 2 of u squared du. And that makes it so I won't have to back substitute. So I've got 4 plus 2 times u cubed over 3 from -1 to 2. So plugging the upper bound in, you'd get 8/3. Plugging in the lower bound, you get -1/3. Okay, so now we've got 4 plus 2 times, that looks like, what is that, 9/3, so 3. And so we're going to end up with a nice even 10 here. So I'm going to go ahead and bring my original prompt down. There we go. Okay. All right. Way more steps than you probably showed, but there it is. All right, my friends. Moving on to part C. All right. It says from -5 to 6, so I guess that's the whole picture, on what open intervals, if any, is the graph of f both? So you're looking for f to be both increasing and concave up. Give a reason for your answer, okay? And I'm going to give the long-winded version here, but what I'm about to write could, of course, be summarized in a much smaller, shorter way, okay? But I just want to be as clear as possible on this one, okay? So for part C, first let's look at when is f going to be increasing, okay? So the graph of f will be increasing when its derivative is positive, okay? But you're gonna need to be able to look at the graph of g, so luckily we figured out f prime is just g, and so the statement would be the same as saying that is f will be increasing when, and just replace f prime with g. So you're looking for, on the graph of g, when is g of x greater than 0? So that would just be when g is above the x-axis, because you're just talking about when its y-coordinate's positive. So, so that would be, if you look at the picture here, that would be, so g is above the x-axis from 0 to 4, not including 4, and then from 4 to 6. So, so this would be, so f is increasing for all x from, what did I say, 0 to 4 in union with 4 to 6. Okay, so now let's look at when is the graph of f concave up. So we'll just kind of pull these two things together, okay? The graph of f will be concave up when f double prime is positive. Okay, so now let's translate that statement to be in terms of g. So look up here at the primary relationship. If you take the derivative of this side, you'd have to take the derivative of this side. So f double prime of x would be the same as g prime of x. So, so that means that is, I'll just use the same style of explaining. That is, we're looking for when g prime of x is greater than 0. Okay, so if you look at your picture, this is the graph of g, so g prime would be the slope of the tangent line. So we're looking for places where the slope of the tangent line to this graph would be positive. So that would be, you could see the slope of the tangent line is positive here. It's positive here, 0, negative, and then positive on this interval right here, okay? So f is concave up for all x from 0 to 1. Wait, no, I missed one, sorry. Oops. -2 to -1, that is. And then 0 to 1. And then from 4 to 6. Okay, so if you're looking for when your graph will both be increasing and concave up, then you'd be looking for the intervals that make both true at the same time. So you're just looking for the overlap. So therefore, the graph of f will be increasing and concave up for all x element of, let's see, -2 to 1, you have concave up, but you don't have it increasing. 0 to 1 would be included here, so and then 4 to 6, not including the 6, showed up in both. There we go, my friends. That's it for part C. Okay. Moving on to part D. It says, find the x-coordinate of each point of inflection on the graph of f. Give a reason for your answer. My friends, for graphical reasoning type questions, you want to stay away from the procedure we used when we had like a given function rule and we were asked to find points of inflection, where the process then that made sense would be to set f double prime equal to 0 and then go from there. You're going to be a bit miserable if you think that way from the graphs, okay? So we're going to jump to the next phase of finding points of inflection, where you'd not only be looking for when f double prime is 0, you'd be looking specifically for when f double prime changes sign, because you're looking for when the graph would change from concave down to concave up, okay? So you're going to be looking for when f double prime changes sign. So that's how I'm going to start my explanation here. So for part D, a point of inflection of the graph of f will occur when f double prime changes sign. That is, You're looking for when G prime changes sign. Okay, so now let's look at, since this is the graph of G, let's look at, what's G prime on different intervals. So G prime from -5 to -2 is 0. And then we had already established G prime from -2 to -1 is positive. G prime from -1 to 0 is 0 again. And then you've got a positive derivative, you go to 0 here, and then you go to a negative derivative, and then you go to a positive derivative. So if you look, the only x value where G prime, aka f double prime, changes sign would be right here at 4. The other places you don't have a change in sign, going from 0 to positive is not a change in sign, for example. So we'd end up with just 4 being your only inflection point. So just finishing this out, we would say thus, or whatever transitional word you want to use, F will have an inflection point at just x equals 4. There we go. All right, my friends, I hope you found this helpful for whatever pieces of this problem you had questions about. This is a very typical type of question that we've seen on a lot of AP exams in the past, so it's a really good one to practice, and I hope everybody's doing great. Take care, everybody.